Hey physics class, how's it going? We got our new topic this week of circular motion. There's going to be some new formulas that kind of go into it, and I'm going to explain each one as we kind of go. But let's kind of just do a little intro into what circular motion is. I mean, obviously, you all know what circles are, even as bad as it's drawn by me. But let's kind of go into a look at what this means kind of physics-wise for some of our very basic components of maybe like velocity or distance or time, and then especially acceleration as well. So what are some things that we can kind of like, let's say you are moving in, like running around a track, okay, perfectly circular track, not an oval one, but a perfectly circular track, okay? There's some things we can, let's talk about velocity, distance, time, and then acceleration. All right, velocity. Velocity is, again, just a speed in a certain direction. That's the major thing, though, is a certain direction, okay? So when we talk about velocity, I'm heading 20 meters per second east, 20 meters per second south, 20 meters per second north. And the thing is, I need a direction with velocity. The problem with circles is that we consistently keep changing that velocity, that direction, which means we are kind of changing that velocity. Even if I'm going 20 meters per second here, and 20 meters per second here, I'm going in two totally different opposite directions, which means I'm consistently changing velocity. So we have changing velocity, just all the time. Okay, and it may not be the magnitude, it may not be the number, but a lot of the time, obviously, it's the direction in which you're moving. All right, distance. How can we think of it as a distance? Well, we can think of this as our circumference. Okay. Which will make it a lot easier, which is 2 pi r. So basically, if I have a radius, the way I can figure out a circumference is 2 pi r. All right, so we're going to be using that kind of a lot as we kind of go through this. Time. We could use a certain amount of seconds, okay, there will be some questions where it's like, Johnny did a lap in so many seconds, and that'll work. One that we always like to use, though, and this is going to go back to a little bit of grade 11 work, a little bit, is if in waves. In waves, we talk about frequency and period. And period is the one that we're going to want to care about here. Period, which is an uppercase T equals time over the number of times something happened. So let's say it took Johnny 20 seconds to do one lap. That's the time period that we're going to actually use. It took 20 seconds to do one thing, to have one revolution, okay, to have one full circle. Okay, and so that's what a period is. When it says like it's the time over the number of things, that's what we're looking at. It's the amount of time it takes to do one revolution. And that's what we're using a lot of, and that's what's going to work into our formula bunch, is this period symbol, which is an uppercase T with kind of a slanted top. That's actually what's going to show and going to help us through our formulas. Lastly, okay, acceleration. Acceleration, again, is nicely going to work in the sense of it's just going to be, it still works as F equals m times a, but because everything's always changing, the formula that we like the most is going to be this, okay? And there's two, but it's going to be acceleration equals velocity squared over the radius, okay? Now, I'm not going to get into how to derive that too much this time. Maybe in the advanced session I could do that, but that's kind of the formula we're on. Let's look at the 4 formulas that are going to be on your formula sheet and where we got them from, okay? First one, okay, actually one of them we already have. There's one right there, our period. Our period is the time over the number, like the amount of time it takes to go around the circle, and then the number of times you actually went around. So there's our one. Our second one, how do we get velocity? Well, before it was distance over our time. Okay, that's for a regular linear kinematics question. It was just d over t. Well, I've changed my distance to kind of reflect circular motion. So I'm going to put 2 pi r as the distance around the circumference. And then instead of time, we're going to use a period. And so there's one of the formulas that's going to be very, very important to our circular motion is how do we find velocity? We take the distance around the circle and we divide it by how long did it take to go around that circle. So basically the distance divided by time, but we have to put it into circular motion terms. So 2 pi r over period. There's one of our formulas, okay? There's number 1. This is number 2. How do we get that period? Again, it's just the amount of time it took to go around divided by how many times. So there's formula number 2. This is formula number 3 that we're kind of adding in here, our acceleration formula. Again, velocity squared over a radius. We can also kind of change our velocity. If we input this velocity formula into this acceleration one, we can kind of get a different acceleration formula, where we get acceleration equals 4 pi squared r over t squared, okay? And so I'm just going to put a box around these two. That is a horrible box, and this will be much better into your actual formula sheet. But we have 2 formulas that are the same and yet different. These are both acceleration formulas. Okay, one says acceleration equals velocity squared over radius. If I just take that velocity, like this one right here, the 2 pi r over a period, and plug that in squared, you kind of get this. Acceleration equals 4 pi squared times radius over t, actually squared, or t squared. It's like period squared. Okay? And so you'll see me use these questions kind of a little bit in our example questions. But there's another formula. Our last formula, how do I find force? And the nice thing is this one doesn't change. Okay? Last one. Force equals mass times acceleration. Force, and what I'm going to explain in the first question, force says, like, when we have circular motion, we have a force that is always pushing outwards. Okay? If you've ever seen like a graper, that kind of stuff, we put in a jar and you spin it around, it stays on the outside. That's because everything wants to keep going straight. So if we had something on a string going in a circle, if I let go of that thing right there, it would want to go straight. Okay? If I let go of it right here, it would want to go straight. Again, Newton's basically second law. An object in motion wants to stay in motion in that same direction until acted upon otherwise. This is no different. This wants to stay going in the exact direction where it's going. The thing is, something is obviously making it spin in circular motion. So it's going to have a centripetal force. Okay? The force that's acting outwards. It wants to keep moving outwards as it's going. Okay? And so to get that centripetal force, we just put FA for as in angular force is what we're going to call it. And it's what it's called basically universally. So our angular force is just mass times, again, acceleration. We just have to know that this is, again, circular. I put a little C here, circular acceleration. Okay? So basically derived from one of these two. Okay, so F equals ma, that doesn't change. We just have to make sure that we know that that acceleration is coming from one of these formulas here. Okay? And so that force is always pushing out. It's always pushing out when it's going on because it wants to stay going in that outward vector direction. And so that's where we get our centripetal force from. Okay? There's some good videos that I'll have in there as well to kind of talk about centripetal force and other things. But this is just a little intro of some of the words you're going to be seeing and some of the formulas that we'll be working with for circular motion. The next 3 videos, I'll be going through practice questions and kind of picking out the questions that I think are most useful and helpful for diving into this unit first off and kind of decoding how to do these questions and really get through it. So, all right, 3 videos, some exam questions, they'll all come from our practice sheets. Thanks, class. Talk to you soon.